The Sun. It is the star at the center of our solar system, and the one we know most intimately. For billions of years, it has been the reason life exists on Earth, providing the light and heat that makes our planet habitable. At about 4.6 billion years old, the Sun is roughly middle-aged for a star. It is a medium-sized yellow dwarf, roughly 109 times wider than Earth, and composed primarily of hydrogen and helium. The core reaches temperatures of about 15 million Kelvin, hot enough to sustain the nuclear fusion reactions that power it. The Sun is expected to continue shining in roughly the same way for another 5 billion years, at which point it will balloon into a red giant star. Sirius A. This is the brightest star visible in our night sky, found in the constellation Canis Major. It is a binary star system, with the bright component being a blue-white star 25.4 times as luminous as the Sun. It has a radius 1.71 times that of the Sun, and a surface temperature of 9,940 Kelvin, more than 4,000 Kelvin higher than our Sun. Its distance from the solar system is 8.6 light-years. The Sirius system was originally made up of two bluish stars, but the more massive one, Sirius B, consumed its resources and became a red giant before shedding its outer layers and collapsing into its current state as a white dwarf around 120 million years ago. Sirius A will eventually follow the same path and become a white dwarf in its own right.
Pollux. Located in the constellation Gemini, Pollux lies at a distance of 33.78 light-years from Earth and is the nearest giant star to the solar system. It is an orange giant with a mass of 2.4 times the Sun's mass and a radius about 8.8 times the Sun's, with a surface temperature of around 4,666 Kelvin. It shines with a luminosity about 43 times that of the Sun. In 2006, the existence of a planet orbiting Pollux was confirmed. Named Thestius, the planet has a mass estimated at around 2.3 times that of Jupiter and orbits Pollux once every 590 days at a distance of about 1.64 astronomical units in a nearly circular orbit. Ancient astronomers named it after one of the mythological twins of Gemini, though it is actually the brighter of the two main stars in that constellation.
Arcturus. This is the brightest star in the northern hemisphere sky, located 37 light-years away in the constellation Bootes. It has an apparent magnitude of -0.05, making it the fourth brightest star in the night sky. Arcturus has a radius 25.4 times that of the Sun and an estimated surface temperature of 4,286 Kelvin. It is 170 times more luminous than the Sun when accounting for all wavelengths of light output. Its estimated age is 7.1 billion years, possibly up to 8.5 billion years, making it older than the Sun. It has only a third of the Sun's metallicity, but a higher ratio of alpha elements relative to iron, and is suspected to be a population 2 star formed from gas that emerged shortly after the Big Bang. Arcturus will eventually shed its outer shell to form a planetary nebula, leaving behind a white dwarf.
Aldebaran. This orange-red giant star marks the eye of Taurus the Bull in the night sky. It has a mass of 1.16 solar masses and a radius 45.1 times that of the Sun. With a surface temperature of 3,900 to 4,000 Kelvin, it shines with a luminosity 439 times that of the Sun. It is located about 65 light-years away and is the brightest star in the constellation Taurus, ranking as the 14th brightest in the sky overall. About 5,000 years ago, in ancient Persia, Aldebaran was one of the 4 royal stars, considered guardians of the heavens. If Aldebaran were placed where the Sun is, its surface would extend roughly halfway to Mercury's orbit, making it a genuine giant by any measure, though it falls well short of the truly enormous supergiants further along in this sequence.
Rigel. Found in the constellation Orion as a bright blue supergiant, Rigel has a radius 74.1 times that of the Sun and an estimated mass of 21 solar masses. With a surface temperature of 12,100 Kelvin, it shines with about 120,000 solar luminosities. It has an estimated age of only 8 million years. Despite its great distance of around 700 light-years, Rigel is the 7th brightest star in the night sky because of this extreme luminosity. Unlike the cool, aging orange giants we have looked at so far, Rigel is a young, hot, and massive star, burning through its fuel at a ferocious rate. That rapid consumption means it will have a far shorter life than our Sun, likely ending in a supernova explosion within the next few million years.
Antares. This is the red supergiant heart of the constellation Scorpius. The name Antares derives from the Greek, meaning the rival of Mars, since the star lies near the ecliptic and can easily be mistaken for the red planet. Its estimated radius is between 680 and 800 solar radii, with an effective temperature of 3660 Kelvin. Antares is about 75,900 times more luminous than the Sun, though the exact luminosity is uncertain and believed to be in the range of 44,700 to 128,900 solar luminosities. Antares has a blue companion star orbiting it at a vast separation, forming a binary system that telescopes can resolve into two distinct points of very different colors. A 2012 study estimated an initial mass of 17.2 times the Sun's mass and an age of about 12 million years for Antares, making it a young, massive star headed toward a violent supernova.
Betelgeuse. Another star in Orion, Betelgeuse is a red supergiant, roughly 764 times as large as the Sun, located approximately 548 light-years from Earth. Its mass is estimated between 7.7 and 20 solar masses, and its luminosity is about 120,000 times that of the Sun, with a surface temperature between 3,140 and 3,641 Kelvin. Starting in October 2019, Betelgeuse began to dim noticeably, and by mid-February 2020, its brightness had dropped by a factor of approximately 3. A study using the Hubble Space Telescope suggests that the dimming was caused by a surface mass ejection, where material was cast millions of miles from the star and then cooled to form obscuring dust. In 2025, astronomers announced that the 6-year brightness cycle of Betelgeuse could be attributed to a previously unseen stellar companion, a pre-main sequence star orbiting within Betelgeuse's extended atmosphere, expected to spiral into the star within the next 10,000 years.
Mu Cephei. This is the garnet star, named for its deep reddish color and discovered by William Herschel, who described it as having a very fine, deep garnet color. It is a red supergiant located in the constellation Cepheus at an approximate distance of 2,840 light-years from Earth and is one of the most distant stars visible to the naked eye. Its radius is between 1,260 and 1,650 times that of the Sun, and the luminosity is estimated at hundreds of thousands of times solar, depending on the measurement method used. Since 1943, the spectrum of Mu Cephei has served as a spectral standard by which other stars of its type are classified. It is also a variable star, shifting in brightness over time as its outer atmosphere expands and contracts, and it is expected to end its life in a supernova explosion.
UY Canis Majoris. This is a red hypergiant star in the constellation Canis Major, lying at an approximate distance of 3,840 light-years from Earth. With a radius about 1,420 times that of the Sun, it is one of the largest known stars in the Milky Way. Its estimated luminosity is about 270,000 times that of the Sun, with a surface temperature of around 3,490 Kelvin. VY Canis Majoris was first observed and recorded in 1801 by the French astronomer Jérôme Lalande. Observations in subsequent centuries revealed that the star has been slowly fading since around 1850. The eruptions from this star have formed loops, arcs, and knots of material moving at various speeds and in many different directions, making its gaseous outflow more complex than originally thought. If placed at the center of our solar system, its surface would extend to somewhere near the orbit of Jupiter or Saturn.
UY Scuti. Located in the constellation Scutum, UY Scuti is a red supergiant, or hypergiant star, with a surface temperature of 3,550 Kelvin. The star is about 124,000 times more luminous than the Sun. The estimated mass of UY Scuti is between 7 and 10 times the mass of the Sun. Estimates of its exact size have changed significantly over the years as measurement techniques have improved. Older measurements placed its radius at around 1,700 solar radii, which at the time made it a leading candidate for the largest known star. But more recent measurements, based on Gaia Space Observatory data, yield a radius of about 909 solar radii, comparable to Antares and smaller than several other red supergiants, including Betelgeuse and VY Canis Majoris. Despite this revision, it remains an extraordinarily large object, and uncertainty in the data means its true size is still debated among astronomers.
Stephenson 218. This is currently the largest known star, a red supergiant located 18,900 light-years from Earth in the constellation Scutum. With a radius 2,150 times that of the Sun, it would extend past the orbit of Saturn if placed at the
center of our solar system. Its volume is about 10 billion times greater than the Sun's. The star belongs to the Stephenson 2 cluster, first noted by American astronomer Charles Bruce Stephenson around 1990, and its remarkable properties were characterized in a detailed 2012 study. With an effective temperature of 3,200 Kelvin, Stephenson 218 shines with approximately 436,000 solar luminosities. Its mass is not precisely known, and its calculated size already exceeds what current theoretical models predict should be the maximum possible radius for a red supergiant, meaning the star may yet have more surprises in store for astronomers studying the outer limits of how large a star can grow.